Question number 11. A student of mass 60 kg climbs some steps. He travels a horizontal distance of 2.0 meter and a vertical distance of 1.5 meter. What is the work done against the force of gravity? Right. So please remember that work done against gravity is always equal to the gravitational potential energy gained. And the gravitational potential energy can be calculated as potential energy is equal to mass times gravitational field strength times height. Here the mass is 60 kg and the vertical distance or the height is 1.5 meter. So we can write 60 times 9.8, which is the value of gravitational field strength, times 1.5. Now we can calculate it using a calculator. So 60 times 9.8 times 1.5 is equal to 882, which can be rounded off to 880. Therefore, option C is the correct answer. Question number 12. Which method of producing electricity does not involve a turbine? Option A, hydroelectric power station, B, nuclear power station, C, solar cells, or D, wind generator. I hope everyone remembers that in a hydroelectric power station, water rotates the turbine, which produces electricity. In a nuclear power station, steam rotates the turbine. And in the wind generator, electricity is produced when wind rotates the turbine. So the correct option is C, solar cells, because solar cells directly convert solar energy into the electrical energy. Question number 13. The input power to a lamp is 6.0 watt. The lamp wastes 2.7 joule of energy in 3.0 seconds. What is the efficiency of the lamp? So let's begin with the definition of efficiency. It is defined as the ratio of useful output energy to total input energy. So let's first calculate the total input energy, as the input power and the time are given, and we also know the relation between the input energy, input power and the time, which is total input energy is equal to input power times time. Here the input power is 6 watt and the time is 3 seconds. So the total input energy is 18 joules. And we also know that the total input energy is equal to useful output energy plus the energy wasted. Or from here we can calculate the useful output energy, which is useful output energy is equal to total input energy minus the energy wasted. And we have already calculated the total input energy, which is 18.0 joules, and the energy wasted is given, which is 2.7 joules. We can calculate it using a calculator. So 18 minus 2.7 is 15.3 joules. Now we can calculate the efficiency. As the useful output energy is 15.3 joules and the total input energy is 18.0 joules. We can calculate it using a calculator. So 15.3 divided by 18.0 is 0.85. So the correct option is D. Question number 14. A camera is taken underwater and left at a depth of 8.0 meter. Atmospheric pressure is 100,000 pascals and the density of water is 1000 kilogram per meter cube. What is the total pressure acting on the camera? So there will be two types of pressures exerting on the camera. One is the atmospheric pressure and other is pressure due to water. So the total pressure is equal to atmospheric pressure plus pressure due to water. Here the atmospheric pressure is 100,000 pascals and we can calculate the pressure due to water using the formula rho GH. Now 100,000 plus rho, which is the density of water, and it is given in the statement and its value is 1000 times 9.8 times 8 meter. Now we can calculate it using a calculator. So 100,000 plus 1000 times 9.8 times 8.0. And the answer is 178,400 pascals, which can be rounded off to 178,000 pascal. So the correct answer is option D. Question number 15. In which example are the particles in fixed positions? So I hope you remember that particles are arranged in fixed positions only in solids. So here ice in an ice cube is solid. Water in a lake is liquid. Air in an air bubble is a gas. And the water vapor in the atmosphere is also a gas. Therefore, the correct option is A. Question number 16. A gas expands slowly and its temperature remains constant. What happens to the gas particles? Option A. They move further apart and their average speed decreases. Option B. They move further apart and their average speed increases. C. They move further apart and their average speed remains unchanged. D. They stay the same distance apart and their average speed decreases. Let's reread the statement. First he says a gas expands slowly. So if it is expanding, it means the particles of the gas are moving away from each other. And then he says its temperature remains constant. So if the temperature is constant, the speed will definitely remain unchanged, as the temperature and the average speed of the particles are directly proportional to each other. Therefore, option C is the correct answer. Okay, now let's move on to question number 17. The air in each of 4 syringes is slowly compressed so that the temperature of the air stays constant. The volumes before and after compression for each syringe are given in the table. The air in all 4 syringes is initially at the same pressure. Which syringe shows the smallest pressure change? Right. So in this question, he is asking to find the change in pressure, and change in pressure is defined as change in pressure is equal to final pressure minus initial pressure. Here the initial pressure is given. As he says, the air in all 4 syringes is initially at the same pressure. So initial pressure is same, and let's call it P. So now the equation becomes final pressure minus the initial pressure, which is same for all syringes. Okay, so now we need to calculate the final pressure, and we can use the Boyle's law, which states that the pressure and the volume are inversely proportional to each other when the temperature is constant. And mathematically it is expressed as P1V1 is equal to P2V2, where P1V1 represents the initial pressure and initial volume, and the P2V2 represents the final pressure and final volume. So the equation becomes initial pressure times the initial volume is equal to final pressure times final volume. Or for final pressure, the equation becomes final pressure is equal to initial volume divided by final volume times initial pressure. Okay, so now if we substitute the value of final pressure in the equation of change in pressure, so the equation becomes change in pressure is equal to initial volume divided by final volume times initial pressure minus initial pressure. As the initial pressure remains constant for all 4 syringes, so from this equation we can conclude that the change in pressure depends on the ratio of initial pressure to final pressure, right? So to find the smallest pressure change, all we have to do is just to calculate the ratio. So for A, the initial pressure is 50 divided by 10 is 5. For B, 100 divided by 50 is 2. For C, the ratio is 16. And for D, the ratio is 4. So the syringe B shows the smallest pressure. Therefore, option B is the correct answer. Question number 18. The temperature of a substance is measured with a liquid in glass thermometer. Which physical property changes so that the temperature can be measured? Option A, length of thermometer. No, the length of thermometer is not a substance. He is actually asking the physical property of the liquid. Option B, mass of the liquid. No, mass does not depend on the temperature. Specific heat capacity of the liquid, it also remains constant. Option D, volume of the liquid. Yes, the volume of the liquid changes with the temperature and is used to measure the temperature. So option D is the correct answer. Question number 19. Boiling and evaporation are different processes. Which statement is correct? So first let me remind you the definitions of boiling and the evaporation. Boiling is the process in which a liquid changes into a gas when it reaches its boiling point. And evaporation is the process in which a liquid changes into a gas at any temperature below its boiling point, and it only occurs at the surface of the liquid. Now let's take a look at the options. Option A, boiling only occurs at the surface of the liquid. No, it's wrong. Evaporation only occurs at the surface of a liquid. Option B, evaporation only occurs when the temperature of liquid is high enough. It is also wrong. Evaporation takes place at all temperatures. Option C, evaporation does not change the temperature of liquid, which is also wrong. In fact, evaporation lowers the temperature of liquid because the high energy particles escape from the surface, leaving behind low energy particles. Option D, when a boiling liquid is heated, its temperature remains constant. Yes, D is correct. Because at the boiling temperature, the liquid changes to gas, so the temperature remains constant. So D is correct option. Question number 20. A glass beaker contains water. When the center of the base of the beaker is heated, a convection current is set up. Which statement explains this? Okay, so first let me remind you the definition of convection. So convection is the transfer of heat in liquids and gases where warmer, less dense regions rise and the cooler, denser regions sink, creating a circular flow. To understand it, let's consider a layer of gas or liquid containing some molecules. Let's call it layer 1. Let's say for example, its mass is 4 grams, its volume is 1 centimeter cubes, so its density is 4 gram per centimeter cubes. Now consider one more identical layer. Let's call it layer 2. And please keep in mind, as they are identical, so they have same densities. Okay, now if we heat the layer 2, it expands, causing its volume to increase. So now the mass is still 4 grams, but the volume has increased to 2 centimeter cubes. So its density becomes 2 gram per centimeter cubes. Now the density of layer 2 is 2 gram per centimeter cubes, while the density of layer 1 is 4 gram per centimeter cubes. As layer 2 is less dense and warmer, it rises, while the layer 1 being denser and cooler sinks. This is how heat transfer occur in liquids and gases. Okay, now let's check the options. Option A, the evaporation of water causes water molecules to rise to the surface. Evaporation is entirely different process, so it's not correct. The expansion of water molecules causes them to rise to the surface. Water molecules cannot expand, so it's wrong. Option C, the water above the heat source rises because it becomes less dense. Yes, it's correct, right? Option C is correct. But let's check the option D. The water at the side falls because it becomes less dense. No, it's wrong. Because if water becomes less dense, it should rise, not fall. So option C is correct.